So welcome back to my channel. In this video, I'm going to take you through domain of multivariable functions. So when we say functions of several variables, we mean that a function that takes in more than one input, okay? So the basic functions we know is f of x is equal to, let's say, ax plus b, right? When you see such a function, it's taking only one input. So here, this function will receive only x. In a situation when you have f of x, y, let's say z, meaning that this function is going to accept three inputs, that makes it a function of several variables. The focus of this video is to talk about the domain of multivariable functions. So let's see, when you say domain of a function, generally, domain of a function means that we want to know the set of values. So the set of values that will make our function defined. Okay, so set of values that will make the function defined. The function defined. Or you can say that the set of inputs, okay, input specifically. So if we want to determine the domain of a function, we just have to know the set of inputs which when we put into the function, it will make the function defined. That is all. So the goal here is to take any value or the set of values that will make the function undefined out. Okay, so this being a new concept, how do we go by functions with several variables? How do I find the domain? Because I'm now dealing with two set of inputs, one for each of the variables, right? So let's see how we are going to do that using the examples I have here. So now, the first one is a is f of xy. This is equal to the square root of x plus y. So this function is multivariable and is taking two inputs, x and y. It's giving us the square root of x plus y. Okay, so how do I find the domain? It's the same way we know. Whenever you have a radical sign, the set of inputs or the set of numbers that will make this radical sign defined is when what I have here is greater than what or equal to 0. So if the element under the square root sign is greater than or equal to 0, then it means that the value here that this radical sign will produce will be defined. Else, in the real number system, the square root of a negative number is not defined. So this is what you should take note of. So at this point, we simply say that the domain of our function will be defined provided that x plus y will be greater than or equal to 0. Is that not it? Yeah. So this is the condition which we should be satisfied so that our function here will be defined. Therefore, how do we say the domain? The domain simply is let's say you can say x, y, member of all real numbers, where x plus y is greater than or equal to 0. Okay, so x plus y should always be greater than or equal to 0 before this here can give us a defined output. So this is the domain. So you can actually go ahead to sketch it. So when you have x plus y here greater than 0, you know x plus y is going to give us a line, okay? When you have x plus y in an equation form, you're going to have x equals negative y. So this is a line passing through the origin. A line passing through the origin. Yeah. And now you want the right side of it. So every part of it this way. That is. Okay. So now we can say that the domain of this multivariable function is following this side. That is the right side greater than or 0. That is for the first part. Now let's take the second part, the b. F of x, y is equal to the square root of x plus the square root of y. So how do I find the domain of this? So you can see this is also a different way it has been put. It's similar to what we did, but in this scenario, we will take each function separately. When I take square root of x, the domain is going to be x values greater than or equal to 0, right? When I take this square root of y, domain will be y greater than or equal to 0. So at this point, you just get your domain, and your domain is going to be xy member of R, right? Where x is greater than or equal to 0 and y greater than or equal to 0. This simply gives us our domain. If you want to sketch this, if you have x values greater than 0, realize that this is our Cartesian. All x values greater than 0 is going this way, right? Then all y values greater than 0 is coming this way. So you realize that our function is only defined at the intersection here. So anywhere in this region will make our function defined. This is the end of this section. Thank you for being with me. If this is the first time you have been on this channel, kindly subscribe so you get updated when I post new videos. Don't forget to like and share.